So thank you everyone for joining us today. Today we have James Kleeh. He works at OCI. I will let him to introduce himself. So what I'm going to do, I'm going to just share my screen and show a few slides presenting the group. It will be really quickly. So basically we are Madrid-GUG user group. We talk a lot about Ruby and the whole ecosystem. So we have done talks about Ruby, Grails, Gradle, and nowadays we talk more about Micronaut. So even if this is a Groovy group, we also have talks about Micronaut, which is not 100% related to Ruby. Although you, as you probably know, you can use Groovy to create your Micronaut applications. So that is the URL of our group. We have like 8 years of recording talks. Most of, or pretty much all of them are in Spanish. But since the pandemic started, we have a few talks in English. So join us. And if you want to give some talk, just ping me and we can make it happen. So we have an open collective thing just to maintain the group. We are a non-profit thing. We do this on our free time. And basically with the open collective, we can pay for the domain and for the for just a few things that we have. So it's not too much. If you want to support us, that will be great. And basically that's it. Those are our sponsors at Actavis. We are using their Zoom account for doing this. B2Boost, they are a recurring sponsor in our Open Collective. They are a big company. They do a lot of things with both Grails and Micronaut. JetBrains, we will raffle a couple of licenses after the end of the talk, so don't leave it soon. OCI, OCI used to pay the drinks we had when we have meetings in person, and then Greets, we use the script capture for a long time. So basically that's it. This is so if you want to enter the raffle at the end of the talk, just go to that URL or scan the QR code and just put your name there if you are interested. So I will share this link and QR code after the talk. So don't worry if you don't get it now. If you have any questions during the talk, put them on the chat and then I will read them to James after his talk. So that's it. Can you please, James, share your screen, and it's all yours.
Sure. Hi, folks. My name is James Kleeh. I work at Object Computing. I'm the Micronaut product development lead, so I oversee all sort of changes to the framework, mostly to the core of the framework, and as well as our launch-based module. And so today we're going to talk about AOP and Micronaut, and specifically, well, what is AOP, and in Micronaut we have two different types of AOP: introduction and around. What does that mean? And then so I only have a few slides, right? Because I don't like making slides. I don't think people like reading slides. So I'm just going to do a few slides, and then we're just going to jump into some code and go through some examples and of using AOP, and then we'll show how does it work, right? How does it actually work in Micronaut? And then show an example or two of writing some custom AOP, right? And then we'll have some time for some questions. So what is AOP? I pulled that right off of like Wikipedia, right? So it's really about cross-cutting concerns, right? So you have something that needs to interact with other pieces of your code, but is not directly related to the code. So like logging, for example, is a cross-cutting concern. And maybe perhaps tracing is a cross-cutting concern, right? So there's all sorts of things that need to that are related to your code that you're writing, but are not related to the business logic of the code, if that means that means anything. And so the goal there is to increase modularity, right? So it's to make it so that we don't have to put tracing code all over our code, right, in order to actually enable tracing. And that's sort of the goal. Right, and in Micronaut, there's basically two different flavors of AOP. We have introduction and around. Around advice wraps existing business logic. So if you have a method that has some, some code inside of it, you can put an annotation on it, an AOP annotation on it, and that would be an example of around advice. And the implementations of around advice can do things before the method invocation or after it or both. And they also have the ability to sort of manipulate the arguments to the method as well as manipulate the return of the method, right, in different ways. And introduction advice basically has those same things that around advice does, but the idea behind introduction advice is that it is the implementation and is designed to be put on interfaces. So you simply just annotate an interface with an annotation, and then that enables that whatever the behavior of the annotation implies. Right. So so let's do a demo. So in my terminal here, I'm going to create a fresh application with the Micronaut CLI. I do this with the CLI, but you could also do this with the Micronaut launch, right? You just go launch.micronaut.io. And so I'm just going to create an application, and we'll just call it, AOP. And I'm going to use Groovy, right? And I'll use Groovy just by saying -L Groovy. And now we have our Groovy application. And now let's open that up. Okay. So let's show some examples of using AOP. So I think probably the biggest example of AOP that perhaps you've probably already seen is transactional. But that's just, which obviously creates a transaction and commits it after the method gets executed, right? So that does something before the method is executed, it starts a transaction and then it executes the method, and then after the method is done, it closes or commits the transaction. So, but we're going to create something that's going to use, Micronaut has an async AOP annotation that we're going to use, and we're going to give that a try, right? So we're just going to create an async example class. And we're going to have a method here, and that's going to, do something that's going to take a while, right? It's going to call thread.sleep for 1 second, right? And we're going to make sure that this is a beam. So we're going to use with the singleton annotation to say this is a beam, right? So if I were to just inject this beam and call this method, right, it would do exactly, it would sleep the calling thread for 1 second and then return, right? But we can put something on here called @async, and then that will immediately enable this method call to happen, to be offloaded onto another thread, right? And so I'm just going to do like some quick tests here in this application main method. So if you don't know, Micronaut.run in your main method returns an application context. So we can assign that to a variable and then use it immediately, right? So we can say context.getBeam async example, right? And then perhaps in here we'll say like, after we'll do print line done or whatever, right? And so we're going to get this bean and then put that into a variable, call it async. Yeah, that's fine. And then we can let's do a system.out.println, or just I'm sorry, I'm used to Java here. Println start our calling method. and then we can say async example dot sleep, and then print line done. Right. And there's one other change here. By default, when you create an application in Micronaut, it'll create like a web server. And I don't think we really need that in any of our examples here. So I'm just going to change this to none. And then in my main method, I'm going to close the context after we're finished, right? So let's just go ahead and run this and let's see what happens. And I think it's going to tell me I need Java 11. Yeah. All right. 1 second. Also, by default, we use Java 11. Okay, so you see that we got our done calling method printed out before our done, right? And that's because this was offloaded to another thread. So the this AOP annotation here is working and doing what it's supposed to do. So so let's just take a look really quickly and see how how does this actually working. The first thing to notice is that if we were to do something like calling method on, and we said async example dot class dot name, let's go ahead and run that and see what it prints out. You'll see that it's AOP dot $async example definition $intercepted. So that's not our class that we wrote, right? So when we compiled this application, Micronaut generated this class for us. And when we run the application and we retrieve a bean of type async example, it's going to return this, which is a proxy, instead of our actual bean. And if you just open up the build classes folder, you'll see it's it's right here, async example definition intercepted. And we can actually look at this class right now. And the interesting thing about this one is that it extends our class. And so this is why in Micronaut, you can't apply AOP annotations to final classes, because the generated code extends your code. And the extending of your code is a good benefit in this case as well, because if I had another method on here and I called sleep from that other method, the AOP would still apply, right? Because we're calling the method on the we're calling it on the extension, right? We're not calling it directly. So so if we take a look at this, you can see it overrode the sleep method, and it no longer does what the original one does. Instead, it creates this method interceptor chain. And we don't need to get into like super high detail about what this does, but basically we're going to have an array of interceptors that are going to be retrieved when this bean or this class gets instantiated, right? So it calls this interceptor chain resolve around interceptors. So this is the code that executes, that determines which interceptors should be applied to this method execution. And then that gets stored right here into this .interceptor 0. And then that array of interceptors is then retrieved when we call the method, and then passed into this method interceptor chain. And then we call proceed on that chain, right? So in the proceed, it basically just loops through the interceptors that are there. And then if we get to the end, then we will call the target method, right? Excuse me. So execution handle.invoke will call the method on the target, right? The proxy target, which in this case would be our class. And so if we were to look at So that, I mean, that's the gist of how it works is we get our array of interceptors and we loop through them in a chain. And if anytime any one of them returns directly, then we wouldn't ever even call the method in question, right? It would just return immediately, and that's the value that you would get, right? Because it just returns interceptor.intercept. So yeah, and so there's a bunch of other things that get generated too, but we don't really need to be that concerned about it. But the thing to understand is that you're when you retrieve the bean, you're not actually getting your bean, you're getting this thing, and this gets the list of interceptors and then calls those interceptors, and because those interceptors are separate classes in this case, it's pretty easy to create your own and debug it and whatever. So why don't we do that? We can create our own AOP, and in this case, let's maybe one that just will just track how long it took to execute the method, right? And so we're going to call this one timed. So create a new package, and so we just create an annotation. And so everything, so because Micronaut is like a polyglot framework, you don't need to write parts of it in Java, right? And like you can write every single thing all in Groovy, right? There's no limitation on language throughout any piece of the framework. So we'll just call this timed. And so like all sort of standard, if you write annotations, you would want to say documented, and we need to say its retention. The retention is determines if the annotation is available at runtime or not, or just at compile time. Right. And then we also need to add one other thing to this, and that's at around, to say that this is an around advice annotation. And that's all that we need to do there. And then we need to write an interceptor. And to do that, we can just say like timed interceptor. And we need to implement method interceptor. Right? And we don't care about the type or anything like that. This could work on anything. Okay. And then the next thing that we need to do here is say at interceptor bean and tell Micronaut what annotations we're interested in intercepting. So in this case, it'll be timed, right? But you could apply this to other annotations just by, we could say, this should apply to async as well, right? You just do that, right? Pretty easy. And so this is our interceptor. And so if we just left this as is, return null, then it would just return null. It wouldn't actually ever call the target method. And let's create an example here. So we could say, timed service, and we'll have this be a bean. And we can have a method, say have a method that, maybe returns a string, get message. So we want to see, how long is this going to take? So we just annotate this with that timed. And now our interceptor will apply, right? And then let's create some code here to actually call it. So we can just comment this out for now. So we can say context.getBean, timed service, and we'll say dot get message, right? Is that what it's called? Yeah. And so in our interceptor, the first thing we'll probably want to do is like, what is the current time, right? So you can say long start equals system.nanotime. And then we can, then we have this context object, right? And this context object has basically all of the information that you'll need. right? It has the most important being the ability to call the next object, the next interceptor in the chain, or the method itself, right? And you do that with context.proceed. Right, and so we can put that into a variable, whatever it returns, and then we can log how long it took to actually do the thing. So it's like what is it, like time unit dot nanoseconds dot 2 millis system dot nanotime minus start. Right, we can say print line, it took many milliseconds. Whoops. And then we can return, you know, so this would be the return value, right? So we can say return that value. So if we wanted to manipulate that value, we could just do so right here. So let's give this a try and see if it works. I made a critical easy mistake to make while writing Groovy code. This is the Groovy lang.singleton annotation and not the Jakarta.inject.singleton annotation. I think we get like at least one person in the getter, you know, saying, hey, why isn't this working? And it's that. So it says it took 44 milliseconds, right? And I suppose I should probably like print this out to you, just so we know like what we're getting back from it. Right, so it took 33 milliseconds and we get hello. So that's an example of AOP that we just wrote here in, you know, 10 minutes. So it's pretty easy to get up and running. But what if we also had let's say we had another method here and it was annotated with that timed, but instead of it just returning a string, it returned a publisher. Right, so publisher string get message publisher. All right, so if you're familiar with reactive streams, you'll know that when you return a publisher, it generally the method will return immediately, and no actual work is done until you subscribe to the publisher. And so with our current implementation, it really wouldn't work for this use case, right? Because it'll always say it took 10 milliseconds or, you know, whatever, instead of, you know, how long it would actually take. So to help us create a publisher, I'm going to add a dependency to Reactor. So Micronaut has a Reactor module. You don't, in this case, we wouldn't necessarily need the Micronaut one, but it's always a good measure when working with Micronaut applications to do this, because this will include any of the converters or anything else that you may need for it to work with the Micronaut application. So we have that. So let's just go ahead and refresh this. And now in our time service, let's create a publisher, right? We can say return, we can say flux create, right? And in this case, you get something to emit items with. And we can say emitter dot on next, emitter dot next world, right? And then emitter dot complete. And so this will just get returned. And then one other thing that I want to do is say dot delay delay elements, duration dot of seconds, 2. So these items will be delayed for 2 seconds, right? So when we're talking about how long is this thing going to take, it should include this sort of delay. Here. There you go. That makes it happen. So let's just try this out as is. Let's do this. Give this a variable. And then we can do the first one, service.getMessage. And then we can say service.getMessagePublisher. And we'll have this return a flux. So we can use that without having to convert it again. And then we can just subscribe. And we will get the string. And then we can print line the string, right? So let's see what this looks like. Oh, I'm not print lining this one. And if the context is closing before this is finished, so I'm going to do this. So you can say it took 212 milliseconds, right? So we know that's right. I'm not quite sure why it's not print-lining the string here. Next world, complete. That's interesting. But let's try that. I just want to see if we're getting here. Well, imagine so, because we're calling context.close. That's interesting. Well, I'll try and figure that out in a moment. But you could see that this is wrong, right? 229 milliseconds is not greater than 2 seconds. And so in this case, when we have value, it's just an object, right? We don't really know what it is. But we've created an API specifically for use in AOP in order to be able to deal with the return types of methods. And it's called, you just use this static method. It's called intercepted method.of, and you pass in the context. And then this will give you all sorts of useful information. The first thing, the biggest thing that you can do with it is you can check to see what is the result type. So there's a method.result type, which returns a result type. And so there's completion stage, publisher, and synchronous. So did somebody return a completable future? Did somebody return a publisher? Or did somebody just return like a string or a POJO or whatever? And then you can alter the behavior of your interceptor based on that, right? So we can say like switch method.result type, case result type dot synchronous. So in the case of synchronous, this is probably what we want to do, right? But in the case of result type dot publisher, we would want to do something different. We wouldn't necessarily want to do start until they actually subscribe to the thing. And we wouldn't want to know the end point would be when the thing completes, not necessarily, after each on next. So we're going to use flux again. So the first thing that we'll do is we'll just get the value from the method, and then we're going to convert that to a publisher because we know it's a publisher. We can say flex publisher equals flex.from publisher value. Right. So we have the publisher, and then we can say like return publisher.do on subscribe. So on subscribe, so we get the subscription. We will want to store the start time. So we can store that like in an atomic long. Start. So we can say start.set. And the only reason I'm really using this is because you can't, well, I mean, so I'm used to Java where you can't set non-final things. So it could be the case you could just say long start here and then say start equals whatever in Ruby. But in this case, I'll just say start.set and set the nano time. And then do finally, right? Signal. So this will get do finally will get executed whether it terminates in an error or a completion. So then in here, then we can basically do the same thing, right? And so this will be returned. So there's one issue here, and that's that we're going to be returning a flux. But it could be the case that they're using RxJava, right, not Reactor. And so this would result in a class cast exception because it would try and cast a flux to a whatever, and that would not be good. But we do have a way of handling that automatically. You can say return interceptor or method handle result. Right, and then that will convert our reactor to whatever it is that the method is returning. And then you know, if it's not, let's say we don't want to support completable futures, you can there's a method unsupported. You can return that instead, right? So let's run this and let's see if it works. Let's see.
James, someone suggested in the chat that you probably need to wait in the main method a couple of seconds to let basically the sleep and the delay finish.
Yeah, yeah, I probably could. So I can sort of hard code this. So let's do this. What was this one? Oh, zero or one, right? So then here I could say latch.countdown. And then here I can say latch.wait. And context.close. So let's see if that works. There we go. So, but I don't see the, so this is more of what I was expecting before. But I don't see the thing here. So let's take a look at what's going on with this. It could be the case that we need to, that this is just doesn't have time. So it's, so do finally should print line that. try this. That's interesting. Oh, I think I need to do this here. I'm gonna do my await. There we go. There's actually bombing out, not telling me. So you can see now it took 2000 milliseconds, right? Which is what we expected because in our service, we were delaying those elements by 2 seconds. So that's an example of how you can write your interceptors to be more compatible with different return types, specifically reactive return types, right? Like we can do the same thing here for completable future if you wanted to support that. And yeah, and this code is pretty easy to debug as well, right? So if I were to debug this instead of just run it, you can see we hit the breakpoint immediately. There's no issues. There's no like hidden proxy, behavior. Everything is right here, pretty black and white, right? You can step through each part of it, and pretty easy, right? Same thing here for the second call. Cool. And so that's an example of writing an around advice, right? Or sort of wrapping around something else. We can also create an example of introduction advice. So I'm going to use like email as an example, but I'm not going to actually send any emails because that's a pain. So let's just create an annotation for this. So we're going to pretend that we're going to create like an email client. So we'll create an interface, email client, and same thing as before, documented, and retention. And instead of around, we're going to say at introduction, right? And then let's create a class. Or in this case, it'll just be an interface. And we'll call this like notification service. And we'll annotate this with that email client. And we can have a method on here called, like void send notifications, for example. And then we just create our interceptor, which is the exact same API as before. So email. And the same thing, interceptor beam for email client. And so because we placed the annotation on the class, it will apply to all the methods, right? And so the only major difference between introduction and advice as far as the implementation is concerned is that there is no implementation, there is no like target, right? There is no endpoint for you to proceed to. So you can call context.proceed and in the case, there's different cases where you may not want to actually do the thing that this is supposed to do. And instead you may want to do something else. And so you could call context.proceed, but if it reaches the end of the chain, then it will throw an exception because there's nothing to actually execute, right? So let's just go ahead and compile this real quick. And you can see what Micronaut creates for us. So if we look at email, so we have this email client intercepted. So this is a class that gets created for us. And let's see here, where is our, that's not the one I was looking for. This one, notification service intercepted. So basically the only difference now between this and a round advice is that instead of extending your class, we just implement your interface, right? And other than that, it's exactly the same, right? We get the interceptors and we create the interceptor chain and we call proceed. So introduction advice and a round advice, as far as the implementation by Micronaut, almost identical. You know, but sort of their purpose and what they're supposed to do is, you know, obviously different. So in this introduction advice, it's really important in this case to know what the return type is, because you have to produce that return type, right? And so if this was a string, you would want to be able to, you know, send, you know, return back a string representing whatever it is. But you also would want, you would also usually want a lot more information about like what's on the method. So in our email client, you know, perhaps we would want to have an annotation to represent like who's it going to, right? So we can say like @to. And in our notification service, we can say @to, you know, string, you know, address or whatever. And so that's who it's going to go to. And then in our introduction advice here, we have access to this context. And this context has all kinds of really interesting methods. One of them is context.parameter, get parameter values. So you can get the values of the parameters. And then you can actually loop through the arguments. Loop through the arguments. And you could say like, you know, print line it dot in the name of the argument. You can then get the annotation metadata on the argument. So you could say has annotation to, right? So let's print line it dot name. And we can do this too. And then in this case, we're just going to return null, and then let's just kind of run it and we'll see what's going on. So let's just do this. So we're going to say context.getBean notification service and dot send notifications to, you know, Kleeh at objectcomputing.com. And then let's run it. Right. And so you can see that we print line the parameter values. So in this case, it's my email address, right, that got passed in. So we have access to the values that are coming in. We also have access to the arguments. So you can see this is the argument address is the name of the argument. And so that's coming from printline it.name. And then true is it has annotation to, right? And so you can get data out of those annotations. You can, you know, check for their existence. You can do all sorts of things. And so the idea is to take all of the data that you have, right, which is the data, the arguments, the argument values being passed in, and then the arguments themselves, their names, their annotations, and then also the annotations on the method itself, right? So if you say context dot annotation metadata, that'll be the annotation on the method itself. So you can combine all of that information together to do something, right? So in this case, maybe we send an email, but you could obviously do anything that you want to do. This API, I think, makes it pretty easy to do so. And I think I'm getting pretty close, and I'd like to leave some time for some questions. And I think this basically covers what I want to cover. So I think we can just sort of end this here and see if there's any questions.
Yeah. Thank you, James. There is one question. Does AOP work in the same way for earlier versions of Micronaut, 1.x and 2.x?
Yeah, so we're in 3.x now, but yeah, the general, the principle of how it works it's been the same since it started. Right?
Probably the new thing is the interceptor bean, right?
Yeah, interceptor bean is new. So previously, like the way it used to, you'd have to say at introduction, and then you have to say at type email client introduction device, right? So that's what you'd have to do before. But this isn't great because then the annotation has to declare what intercepts it. So if you wanted to create an interceptor for some pre-existing annotation, you couldn't do it, right? So putting the power on the interceptor to say what annotations it intercepts is a lot better, because then you can intercept basically any annotation.
Another question, how can I create an interceptor for third-party annotation?
Yeah, just like this, you just put the annotation here. Now, if just by having this, though, doesn't make proxies for your classes, right? So whatever class, so if you have some annotation on here, and this is not like an AOP annotation, you would have to add like at introduced to your class in order to get the or you would have to create an annotation to that and apply this in order to get these beans, or in this case this one, to be created in the first place. If that makes sense.
Mm-hmm. Another one, is it possible to do compile time validation of the AG annotation metadata?
It is. So it's a completely different thing, but there's basically there's a thing called type element processors, which you can create, and in those you can target specific classes, like annotations on the class, and you can inspect the annotation metadata and throw an exception, and that all happens at compile time. So
maybe you can show an example of something we have in core.
Yeah, so in core we have something called a route validation visitor. So this is a type element visitor. So this is what validates your routes. So to, like, if you mistype something in the URI versus the argument name, that kind of thing, there's all kinds of different things that we validate, but you basically create a type element visitor, and then inside of that you have access to the method element, or or the class elements, whatever you want to have access to, and you can get the annotation metadata and look at it, and you can throw an exception if you want to, right? So in this case, we're saying context.fail. That's how you throw an exception.
Another question, any way to intercept with the same elements as aspect J before, after, around?
Any way to intercept the elements before, after, or around?
Yeah, using the same thing as aspect J.
Like the same annotations?
Not sure.
Yeah, I don't understand the question.
So yeah, so This was from Jonathan. He shared a link. If you can see the chat, he shared a link with the annotations used by AspectJ. So there are a few of them. Yeah, those.
Yeah, so we don't use those annotations. This it's not anywhere near the same thing as AspectJ, but it's the same idea, right? Micronaut is able to do all of this at compile time, right? Whereas so it's not the same thing, so we don't use those annotations. That's basically if that answers.
Yeah, so Jonathan said, yeah, I think so. He joined later, so he lost the first part of your presentation. He's asking that with AspectJ you can intercept before entering a method or after. Yeah, don't worry, Jonathan. So yeah, you can you can do that.
In this case, if you can see at this point where this breakpoint is, we're before the execution of the method, and when this thing returns, we're after the execution. So the answer is yes. Yep.
Another one. What's the difference between at interceptor being timed and at interceptor binding timed?
Interceptor being is a wrapper around interceptor binding. So basically you shouldn't worry about interceptor binding. But interceptor binding is the thing that we actually use, right, to bind an interceptor to an annotation. But beyond what but you shouldn't really need to worry about it, you know, anything else beyond what I just showed right here. But like if you look at around, it uses interceptor binding, right? So if you didn't want to use the around annotation, you would have to use this, that kind of thing. But it's basically internal. Yeah.
Okay. Any more questions? I'm sharing again on the chat the link. If you want to enter the raffle of the licenses, sign up there. So another question, can we intercept packages with wildcards?
Can you intercept a whole package? We don't support intercepting like a whole package. We support intercepting an annotation. So I know like in Spring, you can do that kind of wild stuff. And that's because they do it all at runtime. Yeah.
Yeah, another one. Any best practices regarding error handling inside interceptors? Do I just throw exceptions like usual?
Yeah, no, that's a great question. So if during the intercepting you like something went wrong and you need to an exception occurred or you want to throw an exception for whatever reason, there's a cool thing you could say. You can do method dot handle exception, right, and throw your exception in there, right, so you can return this. And then what will happen is if, for example, the method returns a publisher, it will wrap that exception and return a publisher that emits that exception, right? Or if it returns a feature, it'll handle that. It'll return a feature that has an error, right? Or if it's a synchronous method, it'll just throw the exception for you. So yeah, you just pass in your exception in here, and you're good to go.
Excellent. Remember that if you have more questions about this or about anything related to Micronaut, you can join us in our GitHub channel. So we will be happy to help you there. So if there are no more questions, I think we can finish. So thank you very much, James, for taking time today to be here with us. It's been great to having you. And I think that's all. Please don't leave. We are going to do the raffle. So thank you very much and see you on the next meetup. Bye.
Thank you. Bye-bye.